Okay, so I'll be talking about the remainder of my presentation. So this is like the video part three. Um, Here, so in the previous video, I was talking about the recognition model for the cellular communication, and I talked about the word match and the sentence match and how this model can be exploited for different applications of cellular communication. So in this model, in the next section, I'm going to be talking about the performance of the model. So we can see that the different applications that we have: voice banking service, automation of operator service, automated customer care, recognizing speech from radio and voice dictation, and the performance based on the vocabulary size and the noise level and the efficiency of the software. Now, from the above, we can realize that efficiency of the system is not only dependent on the vocabulary size but also on the input noise. Here, the system depends on the type of application it is also used for, and the performance is relative to the application type. Now, for the example of voice banking services, vocabulary size isn't doesn't have to be that big. So only a few words are spoken to give the required command, and the noise levels to be like somewhat low. Uh, and we will have like good efficiency of around 95%. Now, in case of automated customer care or voice dictation, where a lot of data needs to be processed, we need a larger vocabulary size. So from the table, we can see that even with low noise, the efficiency for voice dictation is bad in regards to automated customer care, which has a medium level of noise. So the reason is that there's large amount of data to be processed and it needs to be processed efficiently. So, but the required vocabulary size is the main constraint of the recognition model. And you can see that even in low noise environment with a low vocabulary size, voice dictation is pretty bad. But with a medium noise and environment and a vocabulary size big enough for doing the application, is showing us good results for automated customer care. But we also have to remember that noise plays an important part. So using large vocabulary sizes here, we can say that the efficiency for processing the data from the radio conversation is pretty bad, even with large vocabulary size, because there's a lot of noise between like commercials, crosstalk between the announcers and etc. So that gives us bad efficiency for radio conversations, and we see that it is like low. Plus the efficiency goes down to like 70%, but all over I can say the software gives me an efficiency of 50 to 95%. Now let us look at some of the applications where this software can be used in cellular communication. Now first I'll be talking about applications which are done to achieve cost reduction. So first is automatic operator assistance. And this system is basically implemented for small corporate environments. Your user can put forward a particular query, and the system can analyze that query and respond accordingly, either with the solution or it can basically forward the call to an operator for more information. Now, but for proper implementation of the system, we will need a large vocabulary set and good noise cancellation techniques. And as an example of not using human operators, we're reducing the cost and therefore saving revenue. Next is voice dialing. So the system is similar and it's used for connecting calls between two users. So suppose I do not need the name of the I do not know the number of a person I want to call. I will just simply tell him the name, and the system will basically detect that in its information database, and it will forward the call. So the main thing for the system is basically it needs a good set of database, and it has to know the name of all the users in a particular area where it is implemented. Now if it knows the name, it can match it to its database and it can forward the call. So in this way, not only like are we reducing the cost of using human operators, but we also can generate revenue, as we can like charge the customer for every call that is forwarded. Next, I'm telling about some applications to generate new revenue. Suppose voice banking services. How about we just give a phone call and we transfer a particular amount, or else we can access that account, make transfers, check the account balance. We just don't need to log in to the bank website or visit the bank physically. We're driving a car or we're just sitting somewhere, just give a call and everything is done. And this too can be done without using a human operator. That means there's no cost involved, just the initial cost of setting up the system, and then we can like keep generating revenue for using the service. But here the main thing is we need to implement digit recognition also, other than voice recognition, because that is important as the account numbers and the transaction details will be mentioned. So plus we need efficient noise cancellation techniques also. Next is information services. So your customers are always looking for easy way of access to information without much hassle. So we just give a call and it responds to the request of the customer and it gives us the appropriate response. So whatever the query or the whatever information the customer wants is just like Google on the go, we can say. It's like just call and you say what information you want and the system will do. And suppose the system is unable, it will forward you to an operator. So another way of generating revenue. Third is voice dictation. Now all the carrier networks it can use this. We always have voicemails, but we don't really want to hear them. Instead, if we had them in a text format, so then it'll be easier to read. But while sending a message, we can again send it in a recorded format, and the carrier basically sets it to a text format and sends it back to the receiver. So this technique is efficient in doing a speech to text conversion, and this could be like a premium service. Sprint already offers this, where it converts the voicemail to a text format and it charges it as a premium service. So a good way to generate revenue. Next, we look at the current generation applications that we have. First is a smart agent technology. Now, with all the systems and everything, it's all pretty good in doing the different applications, but it involves a lot of cost as to implement different systems for everything. Instead, how about we just have one system which does everything, from doing it the mobile banking capabilities to doing speech to text, managing phone calls, forwarding, giving information, everything done by the single system. The need of the hour is to develop all in one systems, and that is what a smart agent technology does. For this, it needs extremely large vocabulary sets, good information database, effective noise cancellation techniques, and a very good recognition software, which this software is able to provide. Um, Another important general application is call center attendant. So this is one of the most sought after technology where customer care is utmost important, and we just call and we need proper response and feedback, and therefore we need good response time which can be provided in the system without the use of a human operator. So companies don't really need to invest that much, but then again provide the required customer service that a customer requires. Next, I'll be talking about the limitations of my software. Here, the dynamic featuring of speech signals could be required if is required to have a higher efficiency. Second, I'm using Euclidean distance approach. Instead, if I would have used hidden Markov model, then better recognition capabilities could be achieved. Another limiting factor is the size of the vocabulary database. So a larger size database is needed for efficient performance. And lastly, we are using software to do all the recording and the processing. Instead, if we would have used a DSP unit, we would have had proper results. In conclusion, I can say this: there's a lot of research going on in the field of speech recognition, and the purpose is to make these applications globally available to every region. The quality of improvement depends totally on the recording instruments, the background noise, effective software, vast vocabulary sets. And the main thing of this is just that the main application is to reduce cost. Hiring human operators is very expensive for companies which are huge and have a huge customer database. Instead, we just use this system and that is taken care of without that cost. So it generates revenue plus reduces cost. That's all a company could ask for. Here are a few references for the project that I had used. There's nothing much. It's just like mostly the papers were by Ella Rabiner, which used me to apply this concept sort of communication. Papers by Arnab Pramanik and Rajesh Raha helped me in designing and the wavelet transform to understand. Um, okay, so I will get started with the last part of my presentation. Now, for this presentation, just get this started. Okay, I've already talked about the references. I would like to now thank my professor Wu, who had guided me through this class project with his valuable suggestions. I also sincerely thank him for his good teaching of the subject wireless communication. He has always given us support and encouragement to take up individual projects and take it to completion. Thank you so much, Professor, for your help and support. Uh, this is like the end of my presentation, so thank you. Now I will just give a demo of the software that I have written. Um, it is 200 and some lines of code actually, so it basically shows the performance. I'll just run that real quick. Sayan. Sayan. So you can see if I say the word, it basically again like records and hears you back so that you know whether it's proper or not. Now to check it real quick, I can like it's plots are very okay, yeah. So this is like the original signal and this is the denoised version. You can see that the spikes have been reduced here. So after the denoising is done, this is the filtered version of the speech. It's taken the overlapping pod frames, and this is like the plot after pre-emphasis. This is the plot after doing the windowing of it. Now this is like the 64 point FFT, and this is the mel frequency range that is happens. So this code basically takes it and performs all the features. If I have to run this real quick for another word, let's see. Beautiful Sunday. Beautiful Sunday. So this is like two words, and see each and every one has been detected properly. So let's look at figure 1. Okay, see, so this is like the figure of the original signal, and you can see it's like the denoised version of it. Beautiful Sunday. So it's taken like that. This is figure 3, so I suppose yes, this is a filtered version and shows the figure 4 shows the overlapping power frames. So and figure 5, basically, where is figure 5? Yeah, so figure 5 is the plot after pre-emphasis and figure 6 shows the plot after windowing. Whereas let me find figure 7. Can I find? Not sure. Figure 7, yeah. So figure 7 shows the 64 point FFT of the signal, and figure 8 basically shows us the mel frequency scale, the comparison. So this is how the software works, and the implementation model has been also done. This is the end of my presentation. Thank you so much for being here and listening, and thank you so much, Professor, for your guidance. Thank you so much.